So one more time on that. When we did integrals where the power in the numerator was greater than the power in the denominator, to do problems like this, you guys use long division. Okay? We do long division, we get the answer. That answer is in individual terms, and you can do the antiderivative of each of those individual terms. Okay? So that's what we did earlier. So if you see this, do long division, then do the antiderivative of each term. Okay? Now I'm going to switch that up. Okay? And if you kind of follow along here, we're going to try and do the integral of something where the power in the numerator is less than the power in the denominator. So something like this. Now you've done something similar to this where it was, kind of like the integral of 1 over x plus 3. What is the antiderivative of 1 over x plus 3? Natural log of x plus 3. Okay? We can't do the natural log here because there's a chain rule that would have to be applied.
What if you split it up and made it like x minus 3 and then x?
That's what we're doing.
Oh, okay. And then would you do ln of that plus, times the ln of the other?
It's going to be very similar to that, yes. Yep. Okay? So, you want to pay real close attention here. Alright? We can't just do natural log of this, because the derivative of the natural log of this would give us 1 over this, but then you still have to multiply that by 2x minus 5, and we clearly do not have a 2x minus 5 or even a power of x to begin with up there. Okay? So, I'm going to go back. I'll come back to this one later. Okay? I'm going to just simply review adding fractions. Okay? If you would have to add those two fractions together, what would you have to do?
Make them both have the same denominator.
Make them both have the same denominator. What would that denominator be?
X minus 3, x minus 2.
X minus 3 times x minus 2. So I'd have to multiply the first fraction by x minus 2 over x minus 2. And I'd have to multiply the second fraction by x minus 3 over x minus 3. And then you would have x minus 2 over x minus 2, x minus 3, plus negative 1 times that would be negative 1x plus 3 over x minus 2, x minus 3. Now that you have the same denominator, you can add the numerators together. So x plus negative 1x would be 0x, and negative 2 plus 3 would be 1, and you'd be left with 1 over x minus 2, x minus 3, which, if you multiply that out, would end up being 1 over x squared minus 5x plus 6, which you'll notice that is very similar to the problem that I just showed you before. So your goal is going to try and take something like this and work backwards to get it into two separate fractions. Because you could do the antiderivative of this, it's the ln of x minus 3. You could do the antiderivative of this, it's negative ln absolute value x minus 2. But your goal is going to be to try and go from here, splitting it up into partial fractions. Okay? So, how do we do that? the first thing I would recommend is to factor your denominator. Okay? So that'd be the integral of 1 over x minus 3, x minus 2. So I'd factor the denominator. Your goal is to somehow split this up into two separate fractions so that when those two fractions are added together, this is your answer. Okay? Now, the only thing that we really know about those two fractions is one will have a denominator of x minus 3 and the other one could have a denominator of x minus 2. So that's kind of how we write it. We're going to write it as, and I'm going to throw in a new variable here, some number over x minus 3 plus some number over x minus 2. We don't know what numbers need to go here yet, all right? But I know that when I add these two fractions together, this will be my result. So I got to figure out, what do I need to put here, what do I need to put here, so that when I add these two fractions together, I get this. Jake?
So maybe make both of them have the same denominator, and then just try to see if you can visually just put in as A and B.
Essentially, that's kind of what we're going to do. Okay, I'm going to write it out so it's not necessarily as much kind of just plugging and chugging or guessing and checking, but it's very, very close. Okay?
Couldn't you just look at the negative 5 over 6 and see what the multiply those by to get, so they add and multiply to 6 and the negative 5?
I think you might be able to do that. Let me show you how I would set this up. So we know that we somehow have to make this equal this, right? We got to figure out what A and B values would make these two things add together to equal this. Okay? So I'm going to go to a new sheet here. All right? I'm going to go A over x minus 3 plus b over x minus 2 has to equal 1 over x minus 3, x minus 2. All right? Now what I'm going to do, this is a rational equation. This is going back to advanced math. This is a rational equation. I'm going to multiply everything by our least common denominator. This is my least common denominator. So when I multiply that fraction by the least common denominator, I get 1. And I can tell I'm losing people, so I'll show it. I'm taking this times x minus 3, x minus 2. The x minus 3, x minus 2 would all cancel and you'd just be left with 1. I'm going to take this one times x minus 3, x minus 2. And what do you get?
X minus 2.
A times x minus 2, right? Yep. And then when I take this one times x minus 3, x minus 2, what do you get?
B x minus 3.
B times x minus 3. So I multiplied everything by the least common denominator, and this is where I'm at. Okay? Now, this could have a lot of different solutions, but what we're going to do is we're going to let x equals 2 for a moment. Okay? Because that's going to make this 0. That's why I'm choosing 2. Okay? We're going to just let x equal 2 for a moment. If x is 2, then would you agree that this becomes 0, and a times 0 is still 0, and if this is 2 still, 2 minus 3 is negative 1, b times negative 1 would be negative 1b. So really I just have negative 1b equals 1, right? When x is 2, this is true. So therefore, what is b equal? Negative 1. Okay? Now I'm going to go back and say, okay, well, what if, or for this time, for this moment, I'm going to let x equal 3. And if x is 3, 3 minus 2 is 1. 1 times a is exactly that, 1a. 3 minus 3 is 0. 0 times b would be 0. So 1a equals 1, and a would equal 1. So what we did was we found certain a and b values that could satisfy this equation for a given x value. Okay? And if you take those values and you now substitute them back in, so now you know that a is 1 and b is negative 1, you can rewrite it. Remember, a was 1, so 1 over x minus 3 plus negative 1 over x minus 2 these are the values of a and b that you could use so that this is really equal to this. And now I can do the antiderivative of each one of those fractions separately. My answer will be what? Natural log of x minus 3
Minus natural log of x minus 2.
plus negative natural log of x minus 2, or minus natural log x minus 2 plus c. Okay? So, what you'll do is you'll take a complex rational function, you'll factor the denominator, you'll separate it into two partial fractions, and then you have to solve for a and b using what we did right here. Okay? There's a pretty good example for you to follow over on the right side. And I want you guys to practice. We did number 1, but try 2 and 3 here, and then try 1 through 5. So there's about 7 problems that you'll want to practice. Okay? So that's doing integration with partial fractions. Give those a shot here for probably about the next 25-30 minutes. And then I'll teach the last thing for the day.